Hello, grade 8s. Here's our first video math lesson. I hope it goes well. Let me know in the comments afterwards what you think and if it was helpful or not, okay? All right, so we've done adding and subtraction of integers. And the reason why I'm going back to it again is because it's really important that you get this and you get it like kind of in your head and figure it out. Because as I mentioned before the March break, adding and subtraction of integers is much harder than multiplying and dividing, and you're going to see quite a bit of it when you get into high school math, especially with algebra. So I want to kind of just review it again. So we did the number line strategy. We also looked at the temperature strategy, and I want you to keep those in mind, and I'm just going to give you another thing to think about today. Remember, there's no one right way or wrong way or better way. There's just different ways, okay? So today's idea is to think about subtraction of integers as difference. And when I say the word difference, I want you to think of like a gap between the numbers. You know, math terminology and vocabulary is important, so let's review that really quickly. The product is an answer to a multiplication question. Quotient is the answer to a division question. A sum is the answer to an addition question, and difference is the answer to a subtraction question. And you, when you were younger, probably learned about difference, being the answer to a subtraction question. And let's think today about difference being a gap between numbers on a number line. So let's look at 10 minus 3. Obviously, the answer is 7, right? If I were to draw the number 3 on a number line and 10 over here, well, you guys know that you'd have to skip 1, 2, 3, 4, 5, 6, 7 times to get there. 7. 10 minus 3 is 7. The same applies when we talk about positive and negative integers. Okay, I'd like you to pause the video while you solve the following question. What is positive 10 minus negative 5? All right, so the answer to this question you should have gotten positive 15. Let's talk about why. One way to think about it is you have a hot drink that's 10 degrees and you're taking away 5 ice cubes. You're subtracting negative 5. If you're taking away ice cubes, you're making the drink hotter. How much hotter? 5 degrees hotter. But let's look at the number line version, the difference version of that same problem. On my number line, we have positive 10 here. We have negative 5 here. I want you to think about what is the gap between those two yellow lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's a gap of 15 between the two numbers. And that's your answer, positive 15. I want you to also think of it this way though. And this is what I always do in my head. When the original question was, what's positive 10 minus negative 5? Positive 10 minus negative 5. Okay, here's what I always do in my head. I always try to figure out what's that number, what's it going to take me to get that number to 0? And that's really easy to do in your head because you just do 10 minus 10, which is going to get you to 0. And then I look similarly at the negative number. What's it going to take me to get negative 5 to 0? 5. 10 plus 5 is 15. That little trick that I just showed you at the bottom here, that really only works when you're dealing with two numbers, one being negative, one being positive. one going this way from 0 and one going that way from 0. And I like that strategy in my head. It's the same strategy as the one I did in yellow. It's just, you're just asking yourself, what's that gap? What's that difference between the two numbers? Let's look at another one. Okay, grade 8s, pause the video while you solve this question. Positive 10 minus negative 10. I hope you didn't say 0. And what I'm really hoping is that you're seeing in your head right off the bat, negative 10 is all the way down here, positive 10 is all the way up here, and you've got 0 in the middle. And it's going to take me 10 to go there, 10 to go there. So the answer will be positive 20. I have a positive 10 drink, it's hot, and I'm taking away 10 ice cubes to make it hotter. It's going to give me positive 20. Let's look. Oops, sorry, I went to the wrong slide here. Where are we? Yeah, there we go. So we started at positive 10, and then we are subtracting negative 10. It took me 10 to get to 0. Took me 10 to get to 0. Between the two, we have a total gap of 20. Positive 20. All right, let's look and see if this works for numbers that are not on opposite sides of the 0. Pause the video, please, and solve the following. Negative 12 minus negative 2. So we're going to start with a drink that's cold already, and we're going to take away ice to make it hotter. Negative 10. But I'm going to show you on the number line another way to see this. We have negative 10 here. Sorry. I take that back, I apologize. It was negative 12. We have negative 12 here, and we're going to subtract negative 2. So in my mind, in my head, I'm at negative 12 and I'm at negative 2. And in my head, what I'm actually thinking about right now is that gap, that difference. And there's a couple different ways you could do this. You could look at negative 2 and know that in order to get to negative 12, there's going to be that difference of 10. Another way you could look at it is to say, I know I need 3 to get to 5. 5 is a friendly number. And then from 5 to 10, I'm going to need another 5, another round and friendly number. And then another 2. 2 plus 5 plus 3 is 10. But honestly, I think with these numbers, you can probably just look at it and see that it's a 10 difference. In this case, it's going to be negative because we started with a negative and we're subtracting only negative 2. What happens, Mr. Itza, when the numbers get larger, when it's not so easy and straightforward? Well, here's a cool tip for you. It doesn't always work, but when I see a question like this, I see a negative and I see a positive. So I know they are going to be on two different ends of the number line across from 0. Okay? Sorry, I'm trying to draw these numbers and it's not working too well, so I apologize for that. We got negative 25 on the left, positive 22, and right in the middle-ish somewhere we've got the number 0. So you need to know sort of what it's going to take you to get from negative 25 to 0. That's going to be 25. And you're going to need to know what it's going to take to get from 0 to 22, which is 22. Stack the numbers together. negative 25 minus 22. I know it's going this way because that's subtraction of a positive number. So it's going to be, the answer is going to be negative 47. So you'll notice that when I'm looking at the difference, I'm finding that gap. I calculate the gap to be 47, but I still need to do that mental check at the end. I need to pay attention to the signs, and then I need to determine, is this number getting larger or is it actually getting smaller? In this case, it was actually getting smaller. It was getting lower. It was getting colder because I was subtracting a positive. Let's look at the next question. Looking at the next question, I've got positive 495 and I'm subtracting negative 144. So the 495 is way above zero. And then we've got a subtraction of negative 144, which is quite far away from zero as well. And we'll put the zero probably around here. What's it going to take to get from negative 144 to zero? It's going to take 144. And then it's obviously going to take 495 to get to 495. Sorry, that green line should be extended a bit further. There we go. So I'm just going to stack the method here, use the stack method again. 495 plus 144. I'm going to have to get better at drawing with my mouse here. I can tell right off the bat. This is going to be an important skill moving forward. 639 is what your answer should have been. What happens, Mr. Itza, when we have problems with multiple operators in the same problem? Okay, so for this, you're just going to, first of all, you always have to follow BEDMAS, but then you just break it up step by step by step, one step at a time, okay? So we're going to solve this first. I'm going to leave that guy for later. The next step, he's going to drop down like a Tetris block. Remember, I taught you always keep it in the same order, especially when we're dealing with addition and subtraction. It's really important. 5 minus negative 5. 5 minus negative 5. We've got two 5s on the opposite sides of the 0. So I know off the bat that's going to be 10. Minus negative 3, I'm going to bring that right down like a Tetris block. And I'm going to keep it in the same order. And I'm not going to try to be fancy and solve both at the same step. I'm going to take my time. I'm going to solve it step by step by step. 10 minus negative 3. I'm 10 on the right side of the number line. And I'm negative 3 over here. 0 will be here. I need to go 3 and I need to go 10. I know the answer is going to be 13. Positive. So now that we've talked about some practice problems using subtraction to think about difference, I would like to talk about some real-world applications where integers are actually used in the real world. Let's talk about golf. So in the game of golf, you usually have a golf course with, let's say 18 holes is the typical golf course. Each hole has something called a par. Par means that's what a really strong golfer will score on that particular hole. So if there's a short hole, like an easy hole, par 3 means the golf course wants to see you swing the golf club 3 times to get the ball in the cup. On a longer hole, like much further away, it might be par 5, which means the golf course wants to see you getting the ball in the cup after 5 swings. So as a golfer, a par is kind of a way of guiding you as to where you should be if you really want to be strong. If you golf like Mr. Itzo does, you're always getting a high score, which is very bad in golf actually. You want to get a low score in golf because it means it took you less swings, which means you got the ball there more accurately and faster. Mr. Itzo's not a very good golfer. All right, so let's look at this problem. On the first hole, Mr. Itzo scores, or sorry, not the first hole, the first game, Mr. Itzo scores negative 5, which means actually I did well. I scored 5 strokes under the par, which means I had an okay game. -5. In the second game, when I went back the very next day, I scored +4, which means I didn't have a very good day. It took me 4 extra swings to get all the finish all the holes. What was my average score for the 2 games over that weekend? Pause the video and see if you can add them up. Alright, so you should get an answer of -1, which means if you were to add up the par for all the holes I did on the one day and all the holes I did for the other day, and you average the 2 scores together, I've got a -1, which means it took me 1 fewer swings to complete all the holes on average, which is a good score to do. Golf is, you're always adding like positives and negatives in your head when you're keeping score when you're on a golf course. If you have any experience on a golf course, can you let me know in the comments? I would love to hear your stories of where your favorite golf courses are and how you score. Let's look at one last example before I let you go, is hockey. Hockey uses a plus-minus system to keep sort of tabs of how a hockey player does on his shift. So let's look at the number 5, Ryan Getzlaf with Anaheim. He has played, GP stands for 50 games played. He has 25 goals, 35 assists, for a total of 60 points. What the plus-minus does is it gives you an indication of how Ryan Getzlaf played in relationship to the rest of his team. So on all of Ryan's shifts, when he was actually on the ice playing, he has a score of +24, which means that when he was on the ice, his team scored 24 more goals than they allowed against them, like when the other team would score. And this tells us that he is probably one of the strongest players on the team. He's, in a way, he's carrying the team. And when I look at Anaheim, another Anaheim player over here, Corey Perry, he's got +25. And, oh look, we've got Francois Beauchemin, who's got +25 score as well. Oh, and look, we've got Hampus Lindholm, who's got an Anaheim score of +24 as well. As a hockey fan, I can infer that these 4 players usually play on the same shift. They play as a unit of 4 or 5 of them. I'm not sure where the 5th player is, because usually you have 5 players in hockey on the ice. These 4 guys usually play together on the same shift, and they're pretty good at scoring goals because they have 25 or 24 more goals than they've let in, which tells me that I can also infer that the other 5 players on the Anaheim team are probably lower, but we're not sure where they might be because it depends on how many games Anaheim is winning that year. To break it up another way, in a hockey game, if Anaheim has the score of 10 and Pittsburgh has the score of 3, Anaheim wins 10-3. If Ryan was playing for all 10 of those goals and he was off the bench for the 3 that Pittsburgh scored, he would have a +10 rating. But if he was on the shift if Ryan Getzlaf was playing for all the goals, but also he was also playing for all of Pittsburgh's goals, he would have a rating of +7. If that doesn't really make sense, don't worry too much about it. It's just one of the stats or statistics that hockey players keep with the NHL. You don't need to know that for the assignment, the assignment's pretty straightforward. It's just a bunch of adding and subtracting of integers. So what I would like you to do today is watch the 3 videos that I put from YouTube. Complete the short Google quiz. Don't stress, it's not worth marks, but do the best you can. And then work on the hockey scores and integers assignment. You may decide to take into the rest of the week to finish the assignment, or you can finish it today. It's totally up to you. Thank you, and have a great day.